I'd like to discuss what I call a family of angles. Now, what is common in these four angles, I'll say the family of four angles, is that in 360 degrees, there are four quadrants. Now let's put four quadrants. Now, if we choose one acute angle, just one acute angle, any acute angle, I'll try to draw this axis here. Okay, if we have, this is like 90 degrees vertical, this is 180 degrees if it goes to the left, this is 270 degrees if it goes all around, and this is 0 degrees. So we call this quadrant 1, we call this quadrant 2. Quadrant 3 angles are between 180 and 270. Quadrant 4 angles are between 270 and 360. And what I'd like to do is select any one acute angle. Let's go 3, 4, 5. Let's use a 3, 4, 5 triangle. This is good because this is 5. 1, 2, 3, 4. No, that's 4. Hang on. Let's change that line. I want to use 3, 4, 5. Oh yeah, no, that's correct. That's the one I want. This is 4. This is 3. This is the point 4, 3, which means the radius, the length here, L, is 5. The length of that line would be using Pythagoras theorem, a squared plus b squared equals c squared, and we get 3 squared plus 4 squared equals c squared, which equals 5. C equals 5, or L, I put L equals 5. Now there's an angle in here. This is an acute angle. How do you get that? We could use sine, cos, or tan. You see, sine of theta is opposite of a hypotenuse. Cos of theta will be adjacent of a hypotenuse. Tan of theta would equal opposite of a hypotenuse. Now, if you do arc sine of 0.6, you will get, let's go to arc sine of 0.6. So 0.6, second function, arc sine, we get about 36.9 degrees. So let's go to 36.9 degrees. Now, if we use arc cos of 0.8, because cos of theta is 0.8, oh, I can't get a calculator. Where is it? There it is. I put 0.8 because 4 divided by 5, and then arc cos, we still get 36.9 degrees. And also, if I do arc tan of opposite 3 over 4 is 0.75, right? Arc tan of 0.75, you get 36.9 degrees. You get the same angle, right? Of course, because it is. So this family of angles, I'm going to put the acute angle is about 36.9 degrees. Now there's a family of four angles. This quadrant 1 is simply theta. But quadrant 2, if I was to put a line, the same angle along 4 up 3, you see, same line. If I was to put that to -4, +3, you'd still get the hypotenuse is 5. Here we've got the adjacent side happens to be -4, and the opposite side happens to be +3. And the angle, and I'm going to put the four angles theta, 180 minus theta, because 180 minus 36.9, 180 minus 36.9 is 143.1 degrees. So that is 143.1 degrees. So actually, let me not write it where I wrote it because it looks like this angle is 143. 36.9 is that little angle, 143.1 degrees. Now, it just so happens that sine of 143.1 degree equals opposite over hypotenuse. It still equals 0.6, positive. Cos of 143.1 degrees, thing is, this is negative 4 over 5, negative 4 over 5. See, because this is an angle in the second quadrant. A second quadrant angle will give you negative 0.8, not positive 0.8, because it's a negative 4, right? The x is negative. Every coordinate in this quadrant has a negative and then a negative y value and a positive x value. Every point in the first quadrant is positive. So we're going to get sine is positive 0.6, sine is positive 0.8, tan is positive 0.6. By the way, tan of 143.1 equals opposite over adjacent, 3 over negative 4 equals negative 0.75. So this is 36.9 degrees here, but the angle is all the way around 143.1. From 0, it is 143.1. So if you go to the calculator and you put sine, is the calculator gone? Can I find it again? If you put sine of 0.6, you get, right there. It's not sine of 0.6, it's the angle, isn't it? Sine of 30, was it 6.9? You get about 0.6. Yeah, all right, 0.6. But if you go sine of 143.1, right, sine, you still get 0.6, positive 0.6. But if you go 143.9 degrees and you go cos, it'll be negative 0.8. And if you go 143.9 degrees, it's rounded off, and get tan of that angle, it's negative. Well, this is negative 0.73. However, I've rounded off the angle. 143.9? Yeah. It's a negative value. So what I want to emphasize here is in the second quadrant, sine is positive, cos is negative, and tan is negative, right? So it's important to know in the second quadrant, sine is a positive, cos is going to be a negative number, and tan is going to be a negative number. All right, now I'm talking about a family of angles, and the 4 angles I'm using is the triangle 3, 4, 5 triangle. It's going to look like a bow tie when it's finished. It's very important that my angle each time is 36.9 degrees. The angle is 36.9 degrees. I can use any acute angle. I've just selected this particular angle. This rule here in the quadrant, and I'll put it in red, is 180 degrees plus theta, okay? Theta is my acute angle, 36.9 degrees. So 180 plus 36.9 is 216.9 degrees. Now, I'm talking about this angle all the way around to there, and that is 216.9 degrees. Well, let's look at what sine of 216.9 degrees is. And let's look at cos of 216.9 degrees. And let's look at tan of 216.9 degrees. You can use a calculator. I'm going to use the triangle. Opposite is -3, adjacent is -3, hypotenuse is still a length of 5. Sine is opposite over hypotenuse, -3/5. So -0.6. Cos is adjacent over hypotenuse. Negative 4 over 5 is negative 0.8. Tan, and I'll put approximately here because it's not exactly, all right? So I'll just put approximately. All of these are approximates. This one down here is approximate. And opposite over adjacent is negative 3 over negative 4 because our coordinate is negative 4, negative 3. All coordinates in the third quadrant are negative, negative. And when you get a negative divided by negative, you get positive 0.75. So in quadrant 1, sine is a positive number, cos is a positive number, tan is a positive number. In the second quadrant, tan is a negative number, sine is a positive number, and cos is a negative number. In the third quadrant, sine is a negative number, cos is a negative number, tan will be a positive number. Now, to wrap it up, the family of angles, I'm going to take another line across 4, down 3. And this is the point 4, negative 3. The opposite side is negative 3. The adjacent side is positive 4, and the hypotenuse is positive 5. Well, you will find that sine, well, if this is 36.9 degrees here, then this rule in this quadrant is 360 degrees minus that angle. So 360 degrees minus 36.9 is equal to 323.1 degrees. So sine of 323.1, now 323.1, that's this angle all the way around with that line there, right? That's 323.1 degrees. Sine is negative 0.6 because of negative 3 over 5. Cos of 323.1 degrees is positive 0.8 because it's 4 over 5, right? Positive 4 over 5. And tan of 323.1 is about negative 0.75 because it's negative 3 over 4. So in the fourth quadrant, sine is negative, cos is a negative value, and cos is positive and tan is negative. Notice cos is positive in the fourth quadrant. Notice tan is positive, only tan is positive in the third quadrant. Notice only sine is positive in the second quadrant. Notice they're all positive in the first quadrant, but only cos is positive in the fourth quadrant. So this is there's a little picture I'm going to put. They're all positive in quadrant 1. Only sine is positive in quadrant 2. Only tan is positive in quadrant 3. And only cos is positive in quadrant 4. I need to put charge in my computer, otherwise the battery's going to go flat. So that's a family of angles. I used the angles, and I'll write it up here. The angles I had, the 4 angles were 36.9 degrees, 143.1 degrees. Notice how I got that, 180 minus 36.9. 216.9 degrees, 216.9 degrees. Notice how I got that. and 323.1 degree. 323.1 degree. Now, as a final product, I want to do sine of each one. I want to do sine of 36.9. Then I want to do sine of 143.1. Then I want to do sine of 216.9. Then I want to do sine of 323.1. What do you notice? Okay, sine of 36.9. Let's do that. Sine of 36.9. 36.9 sine. Look at that number, 0.6004 ... Okay. Now I want to do sine of 143.1. Sine of 143.1. Sine of 143.1. This is the family of angles sine. Look at the number. 0.6004 ... Same number. Second quadrant, it's a positive. All right. I now want to do sine of 216.9 degrees. Remember where we got 216.9 degrees? Now let's do sine. 216.9 degrees. It's the same triangle there. It's a congruent triangle in the third quadrant. Sine. Opposite divided by hypotenuse equals negative 0.604 ... Same number, but negative because the opposite side is a negative. Notice in the third quadrant, sine is negative. You see, sine is only positive in the first quadrant and the second quadrant. All right, finally, I want to do sine of 323.1 degrees. Sine of 323.1 degrees. Sine, same number. Opposite divided by hypotenuse. It's the same triangle. -3/5. It's negative because it's the fourth quadrant. You see, sine was positive in the first quadrant because they're all positive in the first quadrant. They're all positive in the first quadrant. Sine was positive in the second quadrant. We already know that. Only sine is positive in the second quadrant. But sine is negative in the quadrant 3 and quadrant 4, and it's the same value. Okay, if I was to do that same experiment, what I just did, but this time with the cos ratio. You see, if I do cos of 36.9, and then if I do cos of 143.1, if I do cos of 216.9 and cos of 323.1, you try it. You will always get precisely the same number, but sometimes it'll be positive and sometimes it'll be negative. But this answers, it'll be positive in quadrant 1 and quadrant 4, because only cos is positive in quadrant 4, because you've got an opposite is a negative, your adjacent is positive, you got a positive adjacent side, you got a negative opposite side. So because everything in quadrant 4 has a positive x value, your cos ratio will also be positive. And finally, also if I was to do tan of each of these, if I did tan of 36.9, tan of 143.1, tan of 216.9, and tan of 323.1, you will always get the same number, but it'll be positive for quadrant 1 and it'll be positive for quadrant 3, because only tan is positive in quadrant 1 and quadrant 3, right? Only tan is positive in quadrant 1 and quadrant 3. Tan will be negative for all second quadrant angles, and tan will get a negative answer for all fourth quadrant angles, because the opposite sides are, you've always got an opposite and adjacent. You've got a positive and negative, and you've got a positive and a negative in quadrant 3 and quadrant 4. So that's the family of angles. I selected the 36.9 degree angle. I did mention bow tie because, you know, we've got 4 triangles and they looks like a bow tie. It's important that these angles are always the same, 36.9, 36.9, 36.9. And then look at the red rules, theta, 180 minus theta, 180 plus theta, and 360 minus theta. All right, I hope that you've learned something from the family of 4 angles. And we will talk more about this in class.